Okay, Hess's Law practice number 5 from the homework. I'm going to work this out in real time. Actually, I haven't worked this out before. I know what the answer is, but I actually haven't worked through it. So I'm going to kind of like talk through it, how I would approach it, if I were seeing it for the first time. Yeah, and hopefully we'll get the right answer. So all I've done is I've just rewritten the problem here and the equations that I'm given. Before I start, I like labeling the equations that I'm given to work with, like 1, 2, or 3, or ABC, something like that. It's just easier for me to sort of refer to them and keep them organized. Um, okay, so we're looking for the delta H value of the equation in red, and I start by sort of just kind of seeing what's here in this equation and where it is. And so like what I mean is I'm looking, we've got a carbon here in the reactant side. If I look at equation A, B, and C, I can see I've got a carbon in the product side down here, right? Coefficient here is 2, coefficient here is 1. So that gives me sort of like an idea of like, okay, well, I'm going to have to flip equation C to bring that carbon to the right side, to bring that carbon to the correct side, which is the left side. So it gives me like an idea of where to start. I can also see that I've got a carbon dioxide up here in our red reaction. And I've got a carbon dioxide here in reaction A. And again, this one's in the reactants, this one's in the products, right? So flipping reaction A would also be a step. So that just gives me an idea of like where to start. You don't have to work through these reactions A, B, and C in order. You can work with them in any order you want to. And so to illustrate that, I'm actually going to start with equation C. So I see two things that I need to do with this. First, I need to flip it. And then I also need to multiply by a half because I've got to get this coefficient of carbon here 2 to the coefficient of 1 like it is in our red reaction. So I'm going to flip C and I'm going to multiply it by a half. And I'm going to do both of those things at the same time here. So we're going to have 2 times a half, which is 2 carbons, 2 times a half, which is 2 strontium, and 2 times a half, which is 1 SrCO3. I think I was doing the right multiplication, but I think I said those wrong as I was writing that equation. Essentially what we've done is we've divided everything here by 2. And so they all become 1, right? Uh-oh. Look at what I did. I forgot this O2 over here. Okay, so let's erase that. Three halves O2. Okay, and then now we've got strontium carbonate. Okay, our delta H value here, two things happen. We flipped the reaction, so we flipped the sign. This becomes negative. And then the other thing that happened is we multiplied by a half. We divided by 2, so this becomes 1,220, right? Flip the sign because we flipped the reaction, divide by 2. Okay, so now we're done with equation C. We've used equation C. We don't have to worry about it anymore. We've manipulated it the way we need to. So let's see what else we can do here. I'm going to do something with equation A. And the reason I'm going to do that is because here in this new equation that I just wrote at the bottom, I have a strontium carbonate in the products. And here I also have a strontium carbonate in the products, and the carbon dioxide in the reactants. And in the red reaction, I have a carbon dioxide in the product. So earlier we said that we would flip A. And by flipping A and adding it to this, I'm going to get stuff in the right place, and I'm also going to be able to cancel some stuff out. So let's flip A first. I'm going to try to line these up here. So I'm just flipping A around. And then that's going to be strontium carbonate here. And then the sign of delta H flips. So it goes from negative 234 to positive 234. Okay, so I flipped A. and now we're going to add it. Now remember, when we add anything that's the same and the reactants and the products can be canceled. And I think that's only strontium carbonate here. I don't see anything else that can be canceled. And then everything else that's a reactant stays a reactant. And it doesn't matter what order you write this stuff in, just as long as it's on the correct side of the equation. That's all that matters. Okay, so we've got all those. And then our new delta H value is negative 1,220 plus 234, which is negative 986. Okay, so we got that. So we've done A, we've done C, so now let's work with B. Let's see what we got to do here. So for B, in the red reaction, there's no strontium, and I see a strontium here in the products, and I have a strontium here in the reactants. So we can cancel that strontium out. In order to do that, I'm going to have to get the coefficients the same. So the strontium here has a coefficient of 2, and my equation down here has a coefficient of 1. So again, I'm going to do some multiplication here. We're going to multiply B times a half. I'll have to kind of scroll back and forth here to see. So it's going to be SRO okay, and then just SR, and then 1/2 O2, and then the delta H here is 1,184 divided by 2, 184 divided by 2, which is positive 592. Okay, and then we can add together these two reactions, or two equations. Okay, stuff that's the same on either side can cancel out. So I see a strontium oxide, I see the strontium, and then also the O2s. And you can do this before or after you add, it doesn't matter. So this is 1.5 O2, and this is 0.5 O2, which means that we're going to be able to cancel out half an oxygen on either side. So this one goes away, and then this just becomes 1 O2. So carbon plus O2 gives us CO2. Is that the reaction we were looking for? Carbon plus O2 gives us CO2. Yeah, that's our red reaction. And then delta H here is negative 986 plus 592, which is negative 394. And those units are still kilojoules. Just a note about sig figs here. So all of the data that we're adding together have no decimal places, and so our sig fig rules for addition and subtraction are to keep the least number of decimal places. So that means that we keep no decimal places for the final answer, which is fine because it doesn't have any decimal places anyway. But yeah, negative 394. So there we go. So this is a different way than what is shown on the answer key. And so the idea there is there might be more than one way, to solve these problems. And so don't feel forced to do it one way or the other. Yeah, but I hope that helps.